So today we're doing can place flowers. Now this one can be a bit tedious because there's a bit of it's a bit of logic involved. Judging by the acceptance rate as well, 31's pretty brutal. But I've come up with quite a good method for this one. So you can do it with a bunch of like Boolean triggers, and you can do. Let me explain the question first. That'll be a good idea. So we're given a flower bed array, and 1 means there is a plant planted, and 0 means there's an open space that we can plant. And we're given the integer n as our parameter of how many plants we want to plant. So, we have to hold the property of there has to be a space in between each planted plant. So, given here, we can't plant one here because there's a 1 next to it, that breaks the property. But we could plant one here because it doesn't break the property. Because that means it'll be 1, 0, 1, 0, 1. And there's 2 open spaces next to it. So again, you can do this with a bunch of Boolean triggers, but it just gets really messy. By Boolean triggers, I mean like can plant equals true, false, and you have a bunch of them, and it just gets a bit chaotic. I know that because I tried it first. But this method, we are basically going to increment by 2 every single time. And this works great because, let's just do a run through actually of this one. So we have 1, okay, awesome. And then we go 2 more, and we go, awesome, it's a 0. We can potentially plant something here. And I say potentially because this one can't be a 1. So we just quickly check if this is 1. And if it isn't, then awesome, we add it to our counter. And then after we've done that, we increment by 2 again. And this is a 1, so we can't do anything. And awesome, we have 1 free slot. So when our n parameter is 1, it returns true. And when our n parameter is 2, meaning we want to plant 2, it's false because we can't. There's only 1 slot available. So let's go ahead and start coding this in. So we have integer, we'll do integer num, standing for the amount we can place. And let's do our main for loop. Cool. Let's add some space there. So, we're going to have our 2 main conditions. If flower bed I equals 0. So this is our lengthy one, because if it's 1, we can't really do anything, we just skip it. So if it's 0, what we're going to do first, so to check if we can actually increment it, so if, so remember we checked to see if this one wasn't 1, because we remember we said we can potentially plant it here because we need to check this one first. So I'm going to put this in a bracket because we're going to have another condition as well. So if I plus 1 is less than flower bed length, because we need to check that we don't want it to go out of bounds if when we check it, in case it's like here, then we're checking nothing and we'll just break the code. So if I plus 1 is less than flower bed.length, and now we can check it, I plus 1 does not equal 1, then cool. We can go ahead and increment. Num plus plus. But there's also a condition I was waiting to say, when the last digit is 0, we have to increment 1. Because if we end up there, there's no way that this one's going to be a 1. So, we need our other condition, which is or if I equals flower bed dot length minus 1. Awesome. So if it's the last digit, we add 1. If it's the last index, we add it. And if not, we check to see if the next index is a 1, to see if we can't place it. And next, now we just increment our I to go 2 places. So we have to make sure it doesn't break. So if I plus 1 is greater than or equal to flower bed dot length, then we break. Else, I plus plus. Remember, it's going to do another I plus plus here. Awesome. And now we do for 1. Now this one we don't do anything. We literally just do this one. So what this is saying is, if I is the last index, break. Else, I plus plus. That's basically what it's saying. Because we're incrementing a lot. Colon there. Cool. That should work. Now I just need a return statement. Ooh, is that? Return num greater than or equal to n. Run that, make sure it works. Cool. Awesome. So that runs very well. Cool. Cheers, guys.